Let's discuss the solution for saving for a rainy day. Saving for a rainy day is an idiom which says that you'll have to save some money for the future. So how this idiom relates to the question? So let's look at it. Dhaniram is a person who is very hardworking fellow, and with a view of the future expenses, he is about to deposit some cash in his account such that he need not put the cash again and again in his account to make sure that he is taking care of his cash flow demands in the future. So for example, he has got a TV for which he has to pay an installment of 2000 per month for 12 months. 12 months at a stretch. So what he'll do is he'll simply deposit some amount such that from the amount every month 2000 would be automatically deducted and he need not keep a track of it in the future. So that is his basic plan. But if you're thinking that he is depositing 24,000, then there is a problem, because he need not deposit 24,000 though he has to pay 2,000 per month for 12 months. The reason is because the bank has agreed to give him some rate of interest or add some amount as a rate of interest per annum to his savings account. So he has to calculate what is the total amount that the bank is going to add with his amount, and he will be subtracting the value from 24,000 and he will deposit the cash money. Let's say for example, if the bank is ready to add 4% per annum to his savings bank account, so that would be 80 rupees if his deposit amount is 2,000. So assume if Dhaniram is depositing 2,000 in his savings account, and if the bank is agreeing to make some 4% rate of interest or add some 4% rate of interest to his amount being deposited, then that would be 4% of 2,000, which would be equal to 80 rupees. So by the end of the year, he would be able to withdraw 2,080 from the account. So he'll keep the rate of interest also in mind, and he'll deduct the interest amount from the amount to be deposited, and he'll deposit the remaining amount in his account. So this is his basic idea. So our task is to find out what is the amount to be deposited to the bank account, excluding the interest that is being added by the savings or by the bank, such that the sum of interest plus the deposit should be enough to pay the installments properly. So let's try to check out the input format and the output format. So input will be 3 lines. One line, first line is the amount that will be withdrawn from his account every month. So that is M. And T is the total number of months that he has to pay the installment. And third line will tell us the rate of interest at which the amount will grow. Constraints are the amount that has to be paid every month should be greater than 0, and the number of months should be greater than 0, and the rate of interest can be greater than or equal to 0. So we'll check out the test cases to understand better. So here we have a test case where every month Dhaniram has to pay 500 for 3 months, and the rate of interest at which his savings amount will grow per annum is 12. So by the end of the year, there would be an increment of 12% for the cash that he has deposited in his bank. So keeping that in mind, Dhaniram has to deposit some amount. So he has to check if what amount if I deposit in my bank with 12% rate of interest, it would be equal to 1,500. So I have taken 1,500 because every month he has to pay 500, 500, 500, right? So that would be equal. The output is 1,470. So according to the sample test case, only if you deposit 1,470 initially, for which the bank has agreed to pay us 12% increment in his saving account, it would be enough for us to pay 500 per month, it seems. So For example, if the bank has agreed to pay us only 0% rate of interest, then that means by the end of the year, no increment would have happened. That means you will have to spend 1000 or deposit 1500 initially, such that from the 1500 cash, every month 500 would be withdrawn without any problem. So hope the question is clear. Now, let's try to frame a logic by understanding the sample input output clearly. So, if 1470 is deposited for which the bank has agreed to pay 12% interest for 1 year, then it is possible for us to pay 500 for every month, it seems. So, you can wonder, it's only 1470, then how it would be possible for us to pay 500 for three months, which will sum up to 1500. Yes, so let's trace back to understand the problem clearly. So, according to the logic, it would be 1500, but the output is 1470. But there is a clue that bank is agreeing to pay 12% rate of interest over the amount that is being deposited. So, I'm going to go backwards and check if from 1400 it is possible for us to pay 500 every month for 3 months. So, for example, assume Dhaniram has deposited 1470. So, let us check if the value is enough to pay for 3 months. So, first month, how much interest amount would be added to 1470? Let's try to figure out that part. So, 1470 is the initial amount that is deposited, and for 1 year, the rate of interest is 12%. That means for 1 month, it would be 1 by 12 of 12%, isn't it? So, 1470 into 1 by 12 of 12%. So, I am just dividing it by 100. So, 1470 into 1 by 12 into 12 by 100 will give me 14.7. So, I am just rounding it off to the nearest integer, which is 15 rupees. So, by the end of 1 month, my deposited value, which is 1470, would be incremented to 1485. Now, by the end of 1 month, the withdrawal will also happen from the TV company. So, if I drop 500 from 1485, my amount would be 985. So, again from 985, let's try to calculate what is the amount that would be added by the end of next month. So, for every month, it is 1 by 12th of 12%, right? So, 1 by 12th of 12% of 985 is 9.85. So, 9.85, again I am rounding it off to the nearest integer, that is 10. So, if I add, it would be 995. So, again let's try to draw 500 from 995. So, you will get 495. So, by the end of third month, let's try to figure out what is the interest amount that is being added to the sum 495. So, 495 into 1/12 of 12% will give you 4.95, which is equal to 5 rupees. So, when I add, it is equal to 500. So, by the end of third month, when you try to withdraw 500 from the account, it is there. So, by backtracking also, we understood that 1470 rupees is enough to pay 500 for 3 months if the bank is giving us 12% rate of interest per annum. Now, we understood the question properly. Now, the target is to find out what is the amount to be added. So, we easily backtracked it. Now, we'll have to find out this deposit amount. So, let me take it as required amount, and this says time, and this says rate of interest. So, required amount is equal to 500, but we don't know. So, but we don't know what is the cash being deposited, right? So, let me write it as required amount is equal to some present amount. We don't know what is the amount being present initially, right? So, we don't know that 1470 is present initially. So, 1470 plus 1470 with the 12% rate of interest would be there for the first month, isn't it? So, 1470 plus 12% rate of interest would be there. So, from here you will have to try to calculate present amount. So, how would you do that? Just keep present amount to the LHS and bring all these things to, keep present amount to RHS and bring all these things to LHS. So, deposited period is nothing but 1 by 12, because per annum, right? So I'll just make it as 1 by 12. Per annum, the rate of interest is incremented. So for per month means it would be 1 by 12th of the rate of interest. So interest percentage can be given. So in order to calculate interest, you will be making it as interest by 100. So my present amount formula would be like required amount by 1 plus, I just brought these values or known values to one side and I have kept this unknown value on the other side. So present amount is equal to required amount by 1 plus interest percent by 1200. Now let's try to write it in a formula manner, avoiding this many big names to it. So I'm just rewriting everything. So required amount, I'm going to take it as RA, that we know that is 500 for the first month. So RA is equal to present amount plus present amount into rate of interest into 1 by 12. Now I'm taking RA equal to PA. So PA I'm taking it as common. So it would be 1 plus R by 100 into 1 by 12. So I'm just multiplying 12 and 100 together. So it would be R by 1200. So present amount will be equal to RA by 1 plus R by 1200. So you have calculated what is the present amount for the first month. So we'll have to calculate the interest that is being added to the present amount, right? So how will we do that? Interest is equal to required amount minus present amount. And then for the next month, again, you will be incrementing the required amount as required amount plus M minus I. So previously when we were backtracking, we keep decrementing the value. Now we will have to increment the required amount. So for the first month, it would be 500. The next month, it would be some value minus interest. And then the next month, it would be the sum of required amount minus interest that would be accumulated. So pseudocode is simple. So repeat month times. Present amount is equal to required amount by 1 plus interest percent by 12. Interest calculated as required amount minus present amount. And required amount is equal to required amount plus monthly pay. So monthly pay is nothing but the required amount minus interest. That's all about the logic, guys. Now let's try to quickly code the same. Let's discuss the solution for saving for a rainy day. So the question has been discussed earlier in the previous video. Here the question is displayed with input format, output format, constraints, sample test cases, and with the actual test cases as well. So I'm going to choose C++. You can choose any preferable language because the logic and the pseudocode is going to be the same for any language that you choose. So let's get started. I'm going to start my code with variable declaration. So I'm declaring two variables, say monthly pay, which is the cash flow that is required for every month, and the total number of months for which we have to pay. And then as a float value, I'm taking rate of interest. I'm just naming it as rate of interest itself. And the amount and the interest value for every month and required money. Now let's get input from the user. Monthly pay is the first value that he'll give. Second was the total number of months and rate of interest. So we have got all three values. Now let's try to handle the constraints. So if monthly pay is less than or equal to 0 or months is less than or equal to 0 or if rate of interest is, it can be 0 but it should not be less than 0. So if that is the case, then you'll have to simply return the value 0. If not, we'll have to calculate the required amount. So required amount, I'm just copying the monthly pay for the first month. So for the first month, it would be 500. For the next month, it would get added with the interest that has been given for the previous month. So while months not equal to 0, I'm going to simply calculate some values. So I'll just go down. So here, let's try to calculate. Amount is equal to required money. So we know that monthly pay is 500. With that, 1 plus rate of interest by float of 1200. So we already discussed how this formula we have got. So required amount is 500 with 1 plus rate of interest of whatever money we have got. Now we have to calculate what is the interest amount. Interest amount is nothing but 500 minus amount. So now let's update the required amount or required money as required money plus monthly pay minus interest. So next time if you give only this much, it would be enough. So now it would have calculated for first means 0th month as well. So I am going to just subtract the value, first value from it. So required money will be equal to required money minus first monthly pay. So 0th month will also be there. So I am just subtracting it. Now I have to round it off to the nearest integer. So for that, I am just checking if the final amount, I have initially the variable say final amount, and then I am just checking if it's integer, means decimal value is greater than 0.5 or less than 0.5. So how can we do that? So required amount, required money minus 0.5. Say if your required money value is 1470.63, assume. So 1470.63. So if you subtract 0.5 from it, your output would be 1470.13, isn't it? So if I round it off, it would be 1470. If I round it off to using ceil function, then it would be 1471, isn't it? Now, what I'll do is I'll just compare it with the required money. So my required money is 1470.63, isn't it? So I'll just compare it with my required money. So if the final amount is greater than the required money, I'll have to update my final amount as ceil of required money. Right? So how would you round off 1470.63? So 1471 is the proper thing, right? So you'll have to go with ceil function. If your required amount is 1470.4 something, so before 0.5, if you have got the decimal values, it would be rounded up to the actual value minus 1. So for example, if you got 1470.43, then your rounded off value would be 1470 only. But if your required money is something like 1470.63, that means if it's greater than 0.5, then it would be rounded up to 1471. So if you want to round it off to next integer, then you'll have to use the ceil function. If not, you'll have to use the float function. So these two things are not present in IO stream. So we will have to include some other header file. So we'll go quickly and include that as well. So finally, I am printing my final amount. So we'll quickly include the header file over here. That's present in math. So I'm just going to include math. That's it, guys. It's time for us to save and compile. So I'm just minimizing it. Okay, we've got some error. We'll quickly check what is the error. Okay, we have missed a bracket, I guess. Okay, here we missed the division, sorry. So by 1 plus. So we'll check if there is any other error. The line 23 and then in line 25. Okay, here we missed the semicolon. in line 23 before if condition, right? So before if condition, you have this. So we missed a semicolon over here. I guess that's it. Now let's again try to save and compile. Okay, we are missing one more thing. Yes. That's it, guys. All the test cases are clear. I just missed the bracket over here. Maybe because of the zooming. So please make sure that you are putting the total number of open brackets and close bracket as equal. That's it, guys. Thank you.
Hey YouTube, how are you doing? Stay tuned to Facebook for more awesome videos. Don't forget to subscribe.